Hi friends, now let's check the new topic I'm having here with me. I'm going to introduce you guys to set theory. That's introduction to set theory. Now, at first, before I move to the various terminologies under set, I want you guys to understand what set means. What's the meaning of set? You guys are familiar with set of books in a library, collection of different ages together, collection of books together. No, so in short, you can just define set as a collection of what, of different things together. That's just the meaning of set. When you are trying to collect the age of just or the total number of students in a class, you understand the collection of the different age together, the collection of what, of books, textbooks, the collection of books, that kind of thing. That and it's going to occur in what, in just in let's say it's going to call let's take a class for example. Now let's say in a class we have some students that they are 10 years old, we have some students that they are 12 years old. No, they have some students that they are 13 years old. No, 10, 12 and 13. The 10, 12 and 13, they are known as the elements of the set of that set. Let's say the set is just GSS2 now. Each ages that are found in GSS2 is known as the element of GSS2. GSS2 is a set. Shey you get now? So each age that are present in GSS2 is known as what? Is known as the element of GSS2. Now let's just move to terminologies on that set. The first one is subset and superset. What's the meaning of subset? Here I have consider two given sets, A and B. If the set A consists of some all elements of set B, that is, if A should consist all elements in set B, then A is said to be a what? A subset A of B. That is, let's say we have what? We have class JSS1 class now. There are 20 students in the class, and JSS1 comprises of what? Of arts, science, and commercial. Shey you understand now? Set A is JSS1. Let's say set A is JSS1 arts. Set B is JSS1. Let's say SS1 arts. Set B is SS1 science. Shey you get now? Now we have females in set A, and we have what? Male and females in what? In set B. If you look at this now, we can find females in what? Set A contain all what? All elements in what? Set B contain all elements in what? In A. That means our set A is what? Is said to be the subset of what? Of B. And subset is normally denoted as what? As something we call something like this. It's something like this. This is what we call subset. Can you see it now? So this sign represents what? Represents set, and it is called set notations. So this is the notation for subset. Then let's move to superset. If the set A is a subset of B, that is, if A is a subset of what? Of B. Can you see it now? If A is a subset of B and there is at least one element, that is, there is at least one element in set B which is not in A, that is, there is at least one element in what? In B, and it is not what? Is not in B. That means our what? Our set A is called what? Proper subset of what? Of B. Our set A is a proper subset. This is a proper subset of what? Of B. So don't get it wrong. This notation is for subset, while this notation is for what? Proper subset. Then let's move to what? To the next case. The next case is actually the what? The superset. We are talking about superset now. Look at this. A is called the proper subset of B. Then B is considered to be what? The super subset of what? Of A. Now, if there is what? There is at least one element in what? There's at least one element in B, in set B, and it is not in what? In set A. Then you can just say A is the subset of what? Of B. Why B? Look at this. So is a proper subset. This is a super set of A. That's what we mean by superset. So in short, you guys just know that if you have this sign is for what? Is for subset. Can you see now? So if you have these notations, this something like this is a what? This is a proper subset. And if you have this type of notation, let's say something like this is a what? This is a super subset. Superset, or you call it super subset. Can you see it now? So that's just it. Now let's check some example on that. Is we have, if 1 equals to 2 comma 4, comma 8, 6, comma 8, comma 10. If I, let me just say it is I, yeah, and my m is 4, comma 10, my n is what? 6, comma 8, my key is what? 2, comma 4, comma 8, comma 6, comma 10, comma 12. Now, with the definition of the subset, proper subset, and also super subset, we are going to classify them according to what? According to their subset, super subset, and also what? Proper subset. Now, looking at this, what am I having here? If I equals to what? If I equals to that's 2, 4, 6, 8, 10. Then if you look at this now, the first thing I need to consider here is my m. I'm going to refer m to my I now. If you look at this now, I have 4, 10 here, I have 4 here, and I have 10 here. Can you see it now? So in this case, since I can find all elements in A inside I, then here my m is a proper subset of what? Of I. Can you see that? Since m is found inside what? Inside I, that means m is a proper subset of what? Of I. Do you understand now? Then let's move to the next case. If you have, look at my set n. If we look at n very well, we have 6 and also what? 8. Can you see it now? And if you look at set q, we have 6 and 8 now. That means set n is a what? Is a proper subset of what? Of set q. Very simple. Can you see now? Very simple. But if you look at this very well, set n is a proper subset of q. And I told you guys that if at least, look at, so if at least one element is what is found in set b, check it down. If at least one element in set n is found in what? In b, in q, that means my q is what? Is a super subset of what? Of n. If n is a subset, is a proper subset of what? Of q, that means q is a super subset. It's just like you turn it into the what? In the inverse sign, like you change the sign to what? Like this. So our q is what? Is a super subset of what? Of n. Similarly, our I is a what? Super subset of what? Of m. Can you see now? So now, which other case do we have here? We have the case of what? Of subsets. Let's move to subset. Now looking at this, if you look at this, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We have 12 here. If you consider my set I and Q, my I is a what? Is a subset almost equals to, can you see, set what? Q. Can you see that? If you consider this I and Q, we have 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. The only difference is what? Is this 12. That means at least all elements in set I is found in what? In set Q. Which means my I is a what? Is a subset of what? Of Q. Should you get now? So that's just the case under what? Under sets, subset, and superset. Now let's move to equality of set. Equality of set now. If I'm talking about equality of set, that means set A must be equal to what? Set B. That's what I mean by what? By equality of set. Now, two set A and B are said to be equal if A is a subset of what? Of B, and B is a subset of what? Of A. That is, both parties are subset of what? Of each other. That is, both parties are what? Are equal to each other. Now, look at the example under it. State whether or not the following sets are equal. There are some facts under equality of sets. The fact is that you don't consider the arrangement of what? Of the two sets. You don't consider them. In whichever way they arrange it, once you can identify that, okay, your A is equal to B, it will always be what? Be equal. Now look, consider the first case here. A equals to A, B, D, C, and set B equals to what? E, D, A, C. Can you see this now? So in this case, is our A equals to B, A, B, D, C. At least E here, E is major difference between what? Between the two sets. Can you see now? It shows that for this, my A is not equal to what? To B. My set A is not equal to what? To B. Since both parties are not equal. Now checking set F. My set F equals to what? 1, 2, 5. Set H is what? 5, 1, 2. Can you see that at least each element, you don't consider the arrangement. Just check. Are the elements equal? Once they are equal, that's the final. I'm having 1 here, having 1 here. I'm having 2 here, having 2 here. I'm having 5 here, having 5 here. That means for this, my F is equal to what? H. That's what we mean by equality of sets. Then let's move to the last one. We're having 3 here, 5 here, 5 here, 6 here, 6 here, and here 7 here. 7 is not here. That means our set D is not equals to what? Equals to E. But if you consider the case of subset and also superset now, since all the elements here is found here, that means our E is a what? Is not proper, is a subset. Is not proper subset there now, because at least one element is one that is differentiating them. Can you understand? That means our E is a what? Is a subset of what? Or is a proper subset. Now subset, yeah, subset of what? Of G. This is a subset. Can you see that? But because this 7, at least 7 is one that is differentiating them. Let's say you have 7 and 8 here. That means you can just call it proper subset. But since it is only 7 that differentiate them, that is what? That's E. Set E is a subset of G. That's all. Then let's just move to the next case. The next case was complementary set. Complementary set is the set that it's just a set. Is a set. Let's say we have a set. Set A. Set A means all alphabets, all the 26 alphabets. And okay, let's say our universal set is all 26 alphabets, and our set A is just the vowel letter Z. Then our set A complement will be the what? Will be the consonant letter, because set A complement means elements that are not in what? In set A, but they are present in what? In the universal set. Check this. Given that A is a subset of a universal set, can you see that A is a subset of universal set? That is, A is a subset of what? Of our universal set. The element of the universal set which are not in A, in set A, that is the element that are present in what? In the universal set, but they are not in what? In set A. They are constitute a set which you call what? The complement of a set. So they are known as what? As complement of a set. That means A complement, can you see that, are the elements that are not in what? In A, but they are present in what? Universal set. Now let's check the example. A complement can be denoted as what? As A prime, or we call it A complement here. Then moving to example. If the universal set is equals to all integers, if we are talking about integers, that means we are talking about positive and also what? Negative integers, and all other, okay, and A equals to what? All positive integer. Can you see that? So if my universal set is all integers, and all integers include positive and also negative integer, and my set A equals to all positive integer, that means my set A is what? Is positive integer, all positive integer. Let's say our universal set now in this case is -1, 2, -3, can you see that? -4, and so on. And my A constitutes what? That's let me just put 1 here. Yeah, my A constitutes what? 1 and 2, which are the positive integers. Then my A complement, or this, or you use this, A complement will be what? Elements that are in universal set but are not in what? In A. Can you see that? Now all positive integers are what? +2 here, and also what? 1 here. Can you see that? But the negative integer are -1, -3, and also what? -4. So if you are to bring out A complement now, our A complement will be what? Will be all the negative integers that are present in what? Universal set, which is -1, -3, and also what? -4. Can you see this now? So that's the case about the complement of a set. Now let's move to cardinality of a set. Cardinality of a set simply means the total number of elements that are present in a particular set. Now let's say we have what? We have SS3 students now. In SS3 students, we have arts, science, and commercial. The total number of arts, science, and commercial other level students, total number of other level students is known as the cardinality of what? Of that set, of other level set. Shake it down. Now let's say we have what? We have the number of elements in a set is called the cardinality of the set. Yes, the cardinality of the set is taken to be the total number of elements present in a particular set. Now let's check the example under it. Determine the cardinality of each of the following sets. We are given set A, and one major thing that you actually need to understand is that cardinality of set is denoted as what? Let's say you have set A. Cardinality of set A will be what? N of A. Cardinality of set B will be what? N of what? Of B. Cardinality of set C will be what? N of what? Of C, and so on. You can see it now. So in this case, you have set A. Determine the cardinality of each of the following sets. Set A equals to B, E, T, F, G, X. Set H equals to what? A, B, E, F. Look at so G, K. Set G equals to 2, 3, 56, what? 9. Now in this case, how can we go ahead and bring out the word cardinality? You just need to count them one by one. 1, 2, 3, 4, 5, 6. It shows that cardinality of A in this case is equal to what? 6. the total number of the elements. Cardinality of what? Of H, in this case. Cardinality of H, you're having A, B, E, F, G, K. No? They, all of them, they are still, look at so they put them inside what? Inside a brace. That is, they put them inside a bracket. If you look at this, they are still elements. A, B, E, F, G, K, they are elements. So you not to count them together. 1, 2, 3, 4, 5, 6. Since all of them are found what? In H. So you have 1, 2, 3, 4, 5, 6. So you have what? 6. Then moving to what? G. You have G here. Look at this. If you check this case, you're having two numbers joined together. You count it as what? As a whole number. As in whole number, which is you name it, you assign it a value. This is 1, 2, 3, 4. So everything here is what? Is 4. You don't consider the fact that the both of them are together. You now count them over like 1, 2, 3, 4, 5. No. If you look at this, since comma is separating the two elements, that's the reason why I count them all together. But here, you don't have any sign, any trace of comma. So you just count them on 1, 2, 3, 4, which is 4. Then, cardinality of what? Of our T. No set means what? All set of what? Of 0. Check it now. It is not non-zero. They are 0. They are empty sets. Check it now. This is empty sets. Simplification for what? For empty sets. Can you see that? And take note of this. All empty sets, they are the set of what? Or all they are the subset of all other sets. Empty set is a subset of what? Of set A. Empty set is a subset of what? Of set B. Check it now. They are the subset of all other sets. So in this case, the answer is what? 0. Now let's move to what? To the general question under it. Now looking at the general exercise here, given that the universal set is equals to A, B, C, D, E, F, G, H, and so on. You have your set B to be equal to this, your set F to be equal to this. Now the question says find I cardinality of universal sets. Now in this case, let's just go and pick a solution here. Solution. Cardinality of what? Of universal set. No, according to cardinality, I told you guys that cardinality means the total number of what? Of elements present in a particular set. Now, cardinality of universal set will be the total number of elements present in what? In the universal set. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the cardinality of universal set is what? Is 12. That's for our I. Then the II. You are asked to find what? The cardinality of B plus cardinality of L complement. Cardinality of B. The first one is that you need to find the cardinality of B. Cardinality of B equals to what? Total number of B. 1, 2, 3, 4, 5, which is 5. Then cardinality of what? Of L complements. No, I told you that according to complementary law. Complementary law means that the elements that are present in what? Universal set, but not in a particular set. Now, our L complement will be what? If you look at this is my set L. Then set L complement to be the what? Will be the elements that are present in the universal set, but they are not in what? In L. Now, if you look at this, A is here, A is here, B is here, B is here, C is not here. I'll write it out. Then D is here, G is not there, right? Okay, G is there. Can you see it down? K is here, right? P is here. That means I'm having P, I'm having K, I'm having G, I'm having D, and B, A. I'm only left with what? C, E, F, H, L, P, and also what? Q. So in this case now, what's cardinality of what? Of L complements. L complements means what? Cardinality of L complements means what? Total number of elements that are present what? In L. 1, 2, 3, 4, 5, 6, 7. So you're having what? 7. Therefore, this will be what? Cardinality of B will be what? 5 plus what? 7, which is equals what? 12. Very simple. Then let's move to what? To the third case. The third case I'm having here, cardinality of B complements plus cardinality of what? L of L. Cardinality of what? I need to find the cardinality of what? Of B complement. B complement means elements that are what? That are in universal set but not in what? In B. You look at this, I'm having B here, right? I'm not having A. Your A is out. I'm having E here, right? My C is what? Is also out. My D is out, right? What other thing? My G is there. My K is there, right? So my F is not there. What of my P? My P is there. Okay, my L is not here. My Q is not here. And my H is not here. Can you see this now? So I'm having B, that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Is all right. Now let's go ahead and find out our L. The cardinality of L. Cardinality of L is what? 1, 2, 3, 4, 5, 6, which is what? 6. And cardinality of what? Of B complement is what? 1, 2, 3, 4, 5, 6, 7, which is 7. So then, in order for us to find, therefore, our cardinality of what? Of B complement plus cardinality of what? Of L complement equals to what? 6 plus what? Plus 7. Then what's 6 plus 7? That's what? 13. Then move to the what? To the last case, which is IV, our number 4. So you have to find what? Cardinality of what? Of B complement minus cardinality of what? Of L complement. No, cardinality of B complement means elements that are in universal set but not in what? B. And also the same thing as what? As our L. Then if you look at this, cardinality of B complement, I've actually looked for it. Where is it? It is given by what? 7. 7 minus cardinality of L complement, that's 7, which is equal to what? Null set. Because it is what? 0. That's why I said that null set is what? Is a subset of all other sets. Can you see this now? So if you find this video, how can I just put it here? If you find this useful, kindly like and share it to your friends and families. And don't forget to subscribe more on my YouTube channel. Subscribe for more videos and click on the notification button. I'm going to release as much as possible questions, and I will solve a lot of questions for you guys. And another thing is that I'm going to drop a separate video on universal set, the intersection of a set, and also the universal of a set. So stay connected and also make sure you click on the notification button. Thanks for watching.